Welcome to LogicMonitor's product overview training. My name is Sarah Terry and I'm on the product team here at LogicMonitor. I also have Victoria, one of our technical trainers, here with me. Today's webinar will cover a general product overview, and the idea here is to give you a good understanding of the LogicMonitor solution so that you'll be able to set up your monitoring effectively. The specific topics we will cover in today's webinar are getting started in collector installation, devices and data sources, an introduction to alerts, dashboards, roles, and users, and then we'll have a Q&A session for any questions that you may have. As questions come up during the webinar, just enter them into the GoToWebinar interface and we'll answer them towards the end of the hour. So let's begin with what makes the LogicMonitor solution unique. First, it's agentless. You simply install a LogicMonitor collector in each location of your infrastructure, and the collector is just a lightweight Java application, and the collector will then monitor the devices within your infrastructure using standard monitoring protocols, so you're not required to install something on each device. Second, LogicMonitor is a cloud-based monitoring solution, so all of the data from your collectors is consolidated in a single LogicMonitor data center, and this data is accessible from anywhere with an internet connection. Third, LogicMonitor is a hybrid monitoring solution, so it can monitor every aspect of your infrastructure no matter how complex, whether it's on-premise, in a co-location, in the cloud, or any combination of these. And we don't charge per collector, so you can install as many as you need. So the first step in collector installation is deciding where you need collectors. For each location of your infrastructure, we recommend that you install a collector on a server that is physically close to the devices that it will monitor. For example, you don't want a collector to have to communicate across the internet to pull devices in another data center, or through firewalls or network address translation. The server you choose needs to be able to make an outgoing HTTPS connection to the LogicMonitor data center. And this connection utilizes transport layer security on port 443 to ensure that a secure HTTPS connection is achieved. If you are using a proxy server, the collector installation procedure is designed to automatically prompt you for proxy setup when the server can't make an outgoing HTTPS connection. And remember, your collector will be the heart of your monitoring system, so you want to make sure it can keep up. Don't put it on an underpowered or overloaded machine. We recommend that you have at least 1 GB of memory, and preferably 2. Typically, collectors are placed on machines such as syslog servers, DNS servers, or other relatively unconstrained servers. So once you know where you want to install a collector, you can start the installation process. And the collector installation process is really quite simple. It can be completed in just a few minutes. Installing a collector begins with a download from your LogicMonitor account. The easiest way to do this is to download the collector installer from a browser on the same server that you chose for the installation. If the server you chose for installation does not support web browsing, you can use wget or curl commands to download the installer directly to your server, and then return to the browser to verify that the collector installed successfully. Now, I know that most of you are already familiar with the collector installation process, but we do have a lot of brand new users on today's webinar, so we're going to go through it. So we are going to install a collector on a 64-bit Windows machine. So here we are in our LogicMonitor account on the Settings tab in the Collectors section, and we're going to add a collector. And there are 3 parts to this wizard. The first part prompts you to select a machine. We've already selected a machine. We want to install a collector on our 64-bit Windows machine. So we'll hit Next, and we'll choose 64-bit Windows, and we'll download that collector. Now you'll notice that there's also an option to select a collector version. And basically, you have the option here of selecting our General Stable Collector version, which is the minimum required version for all collectors, or you can select our Early Release Collector. And the Early Release Collector version is really more of a beta release, so it's going to have new features and functionality, but we cannot guarantee that it's going to be perfectly stable, and therefore, we don't typically recommend it for your entire infrastructure. So we went ahead and downloaded the General Deployment Collector version 19. If you want more information on the collector versions at the time that you're downloading your collector installer, you can click on this link right here and it takes you to our documentation. If you see any new functionality in one of the early release collectors that you think would be valuable, feel free to give it a try. And if something goes wrong, you can always uninstall that collector and download another collector with the required release version with the same ID. So it looks like our download is almost complete here. And we'll just run it straight from the browser. And this is going to start the Install Shield wizard on Windows. And the Install Shield wizard is going to extract the binary. We're going to be prompted for account information, specifically a username and password. And ideally, this should correspond to an account with admin privileges. And so now it's going to go ahead and start installing the collector. And I also want to highlight our support right now. LogicMonitor has an awesome support team that's available whenever you need help troubleshooting any problems that may come up. And to chat with a member of our support team, you can just select this question mark icon at the top of your screen, and there should be a chat option in that drop-down menu. You'll also see a support request option if you want to go to our support page and make a support request. So it looks like our download is complete here. The collector's been installed. And so now we can verify the connection. And specifically, we're verifying that our collector that has just been installed can communicate with the LogicMonitor data centers. So it looks like that communication was verified. So we'll click Finish. And we can see our collector here with an ID of 108. The platform is Windows. And so now we're going to go through that same installation process on a 64-bit Linux server. So again, we're going to add a collector. We've already selected the machine. It's a 64-bit Linux server. Again, we're going to download the required release. And this time, the way that we're going to do it is we're going to download the collector installer in the browser. And then we're going to use the wget command to download the collector directly to the Linux server. So we'll use this copy wget command functionality. And then we'll open up a terminal and we can SSH into our Linux server. And as best practice, you should become root for this installation process. So we'll paste the wget command into our terminal. And you can see that it copies the entire command to your clipboard, including the output file, the correct syntax, and the double quotes, which is really convenient. And we have the same functionality for the curl command if you would prefer to use that. And then while this is downloading, I will note that we're downloading a binary LogicMonitor setup 64_109. And what that means is the 64 corresponds to the architecture of the download. The 109 corresponds to the ID of the collector that we're installing. And the reason that the ID is 109 is because we've actually already used 108 collector downloads on this account. So if you recall, the collector that we just installed on our Windows server had an ID of 108, and this collector is going to show up in our account with an ID of 109. So now we will make it executable. And then we can run it. And it's going to ask us if we want to accept the default path, installation path. So now it's installing the collector. Great, it's successfully installed. So now we can go back into our browser and verify that this collector can communicate with the LogicMonitor data center. Everything looks good, so we'll hit Finish. And so you can see our two new collectors. Our collector on our Windows platform with an ID of 108, and our collector on our Linux server with an ID of 109. And I just want to remind everyone to enter your questions into the GoToWebinar interface as they come up. So now let's look at what can happen down the road if the server with your collector needs to be taken offline or goes out of service. You can reinstall your collector on a new server. Ideally, you should reinstall your collector on a new server that is similar or identical equipment to the original server. Now, because each collector download has a unique ID, you will need a download with that same ID for the reinstall. So to get a download with the right collector ID, select the arrow next to the collector, and then select Download Collector, and then you can install your collector just like we did in the demo. The only difference is that after reinstallation, there's no verify step, you just need to refresh your browser. So once you have your collectors installed, any remaining configuration can be done from any machine with a browser. So we're now ready to start adding devices to be monitored. So when you add a device in your LogicMonitor account, the Auto Properties step applies built-in intelligence to recognize what kind of device it is. And this device information is populated into the properties table for that device. In addition, each device can have custom properties that you can use to add custom user settings, such as login credentials or a custom port setting. LogicMonitor data sources are templates that contain information about how to monitor a particular device, including what metrics to collect, what graphs to display, and what values indicate an issue that needs attention. LogicMonitor has hundreds of data sources that are pre-configured, which makes it easy to monitor a wide range of devices and applications. So each data source template has an applies to field, and the functions that are specified in the applies to field are checked against device properties to see if the data source template applies to the device. When the data source template is applied to the device, we get a device data source pair. And if the device data source is something where we know there's only one instance to be monitored, such as main memory on a server, the device data source pairing represents a single instance data source. If, on the other hand, the device has multiple data source instances to be monitored, such as disks on a server or ink colors in a printer, the device data source pair is a multi-instance data source. And multi-instance data sources use something called active discovery to locate each instance of a device data source. So for example, the device may be a switch and the data source may be interfaces. So it may not be useful to see latency and throughput, etc. overall, but rather we would want to see it per interface. So the interface's data source would be a multi-instance data source, and each interface would be monitored for latency, throughput, etc. The device data source instance concept is helpful to understand because it is a fundamental concept in other areas of LogicMonitor, such as alerts and alert routing. LogicMonitor data sources are set up to automatically be able to start collecting metrics on most devices using standard monitoring protocols. So for example, the data source for CPU usage on a Linux server uses an SNMP monitoring protocol to collect data. Some devices will require configuration before data can be collected, and for these devices, you should visit our help pages at help.logicmonitor.com, and we have a section specifically for other devices and applications. So these are the default ports used by the various collector methods or monitoring protocols. And these ports are pre-configured in the data source templates. Now we recommend that within your local area network, you have these ports unrestricted between your collector server and your hosts. And again, some devices and technologies will require configuration to access their data. Devices that use SQL, JMX, JDBC, and NetFlow are typical examples. And the configuration settings for these devices are covered in our help pages. And again, that's help.logicmonitor.com. So for your infrastructure, you can look up what ports you're using and customize the properties or values on the data source template based on the information in our help docs. Okay, so now I'll show how to add a device. So here we are in our LogicMonitor account, we're in the Devices tab, and as a best practice, the first device that we're going to add is the server that's running our collector. So let's add a device, and we'll use the wizard. And then let's enter the IP address of our collector machine. And we want to select collector 109 because that's the collector we just installed on this Linux server. And then I'll note here that I already set the SNMP community string for this Linux device at the root level of this account, which speeds things up a bit because basically all devices that use SNMP, the system will try to use the SNMP community that I set at the root level unless I specify a different SNMP community string at the host or group level. And we'll talk a little bit more about properties later in the training, but essentially properties such as an SNMP community string set at lower levels, such as at the device level, will override properties set at a higher level, such as at the root account level. So it looks like everything was discovered. We can save this, and we'll see our device show up here. If we refresh the page, we can see all the data sources that are automatically applied based on the information that LogicMonitor was able to discover about this device. So now we can tell LogicMonitor that this machine has a collector installed on it. And the way that we do that is by selecting Manage, locating the System.Categories property, and giving it a value of collector. And we'll save that. And then we see this group of collector data sources apply. And basically, these data sources are going to report the metrics for the tasks and performances of the LogicMonitor collector, which is just a Java application. So there are four main ways to interface with LogicMonitor. First, there's the data source, which pulls data, and this is essential for monitoring. Second, there's the event source, which is a push, such as an SNMP trap. And this is when a device or a system event wants to tell LogicMonitor that there's an issue. And both data sources and event sources are ways that data flows into LogicMonitor. The third way to interface with LogicMonitor is alert delivery. You can route LogicMonitor alerts so that they're delivered via email, text message, or even a voice call. And we'll go into more details on alert delivery in just a moment in the alerts portion of this training. And in line with alert delivery, you can also integrate LogicMonitor with the ticketing system in your existing workflow. And all of our integrations are explained in detail in our help documentation. So for example, the diagram you see on the right depicts the flow of our ServiceNow integration. Finally, you can use our developer API to interface with LogicMonitor. The API can be used to download data, manage devices, device groups, and collectors, manage alerts, manage dashboards, and more. And again, we have documentation around our API and how to use it in our help pages, help.logicmonitor.com. And both alert delivery and the developer API are ways that data flows out of LogicMonitor. So event sources, data sources, alert delivery, and the developer API are the four main mechanisms for interfacing with LogicMonitor. So let's move on to LogicMonitor alerts. LogicMonitor can alert on data sources, events, services, when a collector goes down, and collector failover. Data source alerts are the most common, and these alerts are based on the values that a LogicMonitor collector is receiving from your devices. A data source alert is triggered when threshold criteria are met. And we tried to do most of the work for you by including default thresholds for most devices in your LogicMonitor account, which means that alerts will be triggered right out of the box. Our strategy here is that LogicMonitor alerting is opt-out rather than opt-in. So we can give you many alerts right out of the box, and you disable the ones that don't work for your use case. LogicMonitor alerts have 3 different alert severity levels, so each data source can have 3 thresholds, one for each severity level. A critical level alert is a worst case scenario. Something is already broken and someone has to take action to fix it. We also have error level alerts, which are less severe than critical alerts. An error level alert should be used for a situation when something is wrong or isn't behaving normally, but there isn't necessarily a specific action that has to be taken. You want to know about these things but they don't have the same sense of urgency as a critical alert. And then a warning alert indicates that there's something you want to be aware of, but it may not be causing a problem yet. And alert severities are a great indicator of how promptly you should address an issue or problem within your infrastructure. Critical alerts are designed to always be reactive alerts, meaning you should react to these alerts as soon as possible because there is a problem that requires your attention. Warning alerts are designed to usually be proactive alerts, meaning we're telling you there may be a future problem. And then error alerts are designed to be more on the proactive side, but you may want to know about them sooner and they may be treated more as reactive alerts. So depending on your use case, error alerts could go either way. So as I mentioned, LogicMonitor has pre-configured default thresholds, so alerts will be triggered right out of the box. Now you may want to adjust thresholds to better fit your use case. So you can customize alert thresholds at the instance level, the data source level, the device level, or the group level. And changes made at a narrower level will override any changes made at a broader level. So I am going to demonstrate how to adjust alert thresholds at both the data source and instance levels. So here I am in the Devices tab of our LogicMonitor account, and we're going to look at the CPU data source for this device. So to change the alert thresholds of the data source level, you select the data source and then select Edit Global Definition here at the top. So this is the WinCPU data source definition. If we scroll to the bottom, we can see the data points for this data source. So we have two data points, CPU busy percent and percent processor time. We can see that right now, CPU busy percent has two thresholds, and that percent processor time has no thresholds. And then we also have an alert trigger interval of 4 for each of these data points. The alert trigger interval indicates how many poll cycles a threshold must be exceeded before an alert triggers. So if we scroll to the top of the data source definition here, we can see that we have a polling cycle of 2 minutes. So if the CPU busy percent is above 90% for more than 8 minutes, we will get a warning alert. So let's say that we really want a warning when the CPU busy percent is above 85% for more than 8 minutes. So we can select Manage for this data point and add a threshold of 85 here. Then we'll click Save. So this means that the warning threshold is 85, the error threshold is 90, and the critical threshold is 95. Now remember that any changes made to this data source definition will propagate to all WinCPU data source instances in your account. So as a best practice, we recommend cloning this data source first before making any changes. Let's say now that you're looking at a particular instance of a data source. So let's navigate back to the Devices tab. We won't save our changes because we don't want them to propagate to all instances of that data source. And let's say instead that we are looking at an instance of this interfaces data source. We can adjust the thresholds for this particular instance as opposed to for the whole data source by selecting the Manage Thresholds for a particular data point. So for the packets outbound discarded and packets received discarded, we can see that the default thresholds inherited from the interface's data source definition are 1. Any changes we make will override this default threshold. So let's change the thresholds for this instance. So let's set the warning threshold to 2. The error threshold to 5, and then we'll set the critical threshold to 10. And let's save that. So there you can see we have our warning, error, and critical thresholds overriding the default threshold. And that's how you set thresholds at the instance level, and this is useful if you only want to change thresholds for a few instances of a data source and not all of them. All right, so let's walk through an example. So let's say we're looking at the total bandwidth usage across multiple data centers for our primary ISP. First, we'll set a threshold for the in-octets data point. And remember that we can set the alert threshold for this data source instance in the new UI by clicking on the data source instance, navigating to the Data Points tab, selecting Manage Threshold for the in-octets data point, and specifying a value. So we set a threshold for the in-octets data point, and to avoid an alert for just a spike occurrence, let's say that we also require that the threshold is exceeded for 3 poll cycles. So we set the alert trigger interval to 3. Then let's say that our bandwidth exceeds the threshold for more than 3 consecutive cycles. An alert will trigger on the 4th cycle. So in this case, if we have a polling cycle of 3 minutes, the condition would have to exist for 12 minutes before an alert is triggered. You can see that if we had an alert trigger interval of 0, we would be notified immediately when the bandwidth exceeded the threshold. The point of setting the alert trigger interval to a longer value, 3 in this case, is to ensure that a persistent and real problem exists when an alert is triggered, and that it's not a false alert. So now that we've covered how to tune your LogicMonitor alerts, let's cover how alerts are delivered. LogicMonitor enables you to route alert notifications to different teams within your organization, so that the right people are notified when an issue occurs. Alert notifications can be delivered via email, text message, or even a voice call. If a recipient is unable to deal with or respond to the alert is automatically sent to the next person in the escalation chain, and this process repeats until the alert is acknowledged or cleared. Additionally, LogicMonitor records your alerts in the LogicMonitor data center and allows you to generate different alert reports. And alert reports are a great tool for warning alerts, where maybe you don't need immediate notification, but you still want to review the alerts. And so there are 2 main components of alert routing: alert rules and escalation chains. The main goal of alert routing is to route alerts to the right people when there's a problem. Escalation chains tell LogicMonitor what people or what groups of people alert notifications should be sent to. And when alerts are triggered, the system checks through your alert rules to determine which escalation chain to route to. For example, you may have a rule that's catching only the alerts for networking devices and sending alert notifications to your networking team. So for this example, we would have the names and contact information for our networking team specified in an escalation chain, and that rule would point to that chain. And an alert can only match one rule, and which rule that is depends on rule priority. I'm going to demonstrate how to add an escalation chain and how to create alert rules that can be used to route alert notifications to this chain. So here we are in our LogicMonitor account. We're in the Settings tab in the Escalation Chains section, and we're going to add an escalation chain that can be used to route critical alerts to our network team. So let's select Add, and we'll name this chain Critical-Network. It's good practice to make your escalation chains with names that make sense. That will help you keep your alert routing organized. And let's add a description that this is going to be used to route to the production network team. And then we have the option to enable rate limiting. And rate limiting allows you to specify a maximum number of alerts that should be delivered to this escalation chain in a specified period of time. So we're going to leave this box checked, and we'll leave the default values of 10 and 20. And this means that 20 alerts can be delivered in 10 minutes. That's the maximum that's allowed. And then we'll add a stage, and we'll set the recipients to the ops network group. And we'll save that. And you can continue to add more stages with more recipients, and as the alert escalates, it will be sent out to these stages in order. But we're going to stop here. So let's save this and navigate to the alert rules. And in the rules table, we're going to add a rule that routes critical network alerts to the escalation chain that we just created. So let's select add, and we'll name it critical alerts networking, and we'll give it a priority of 300. Now the priority for a rule determines in what order it is checked. So when alerts are triggered, they're checked against the rules one at a time, starting with the rule with the lowest number priority until a rule matches the alert, at which time processing stops and alert notifications are sent out to the escalation chains specified in the matching rule. We're going to set the alert level to only match critical alerts and only alerts from the devices in the networking group. And we're not going to specify a specific device in this group. We're actually going to let it apply to all devices in the group. We'll save that. And then we're going to leave the data source and data point fields wildcarded, which means that any data point for any data source for any device in the networking group that triggers a critical alert will match this rule. And then we're going to specify an escalation interval of 10 minutes. And the escalation interval is the amount of time that should pass after the alert message is sent to the first stage in an escalation chain before it is sent to the next stage. The alert stops escalating when it is acknowledged by someone. So since we only specified one stage in our escalation chain, the alert messages will just keep resending to the same stage every 10 minutes until someone acknowledges the alert. So let's make sure to specify the escalation chain that we just created. All right, and we can save this rule, and you can see the rule in the alerts table. So we've just shown you how to route alerts. However, you don't have to have an email, text, or voice alert for each alert, and in fact, you probably shouldn't. Alert reports should be used to address non-critical issues. They allow you to review recent alerts at your leisure, and the reports are customizable, so you can choose what you want to see and when you want to see it. Reports can help you keep an eye on thresholds and make sure that they are properly tuned. They can reveal issues that weren't revealed through alert routing for better understanding of intermittent failures, and then they also detail who has been acknowledging alerts, showing who has the expertise to address similar issues in the future. And viewing proactive alerts, such as warnings, in reports can greatly reduce the number of alerts you're being notified for. So we highly recommend that you use reports to your advantage and only route alerts that require immediate action. So here's an example alert report showing us every alert that was triggered in this account for the last 24 hours. And this alert report is set up by default in your LogicMonitor account. It's called All Alerts from the Past 24 Hours. It's very powerful, and we recommend that everybody take advantage of it. So let's move on to dashboards. LogicMonitor dashboards are a great way to get a centralized and strategic view of your monitored devices. You can customize your dashboards to display information that is relevant to you by adding widgets. Widget types include graph widgets, Google Map widgets, knock widgets, HTML widgets, Flash Player widgets, and more. You can create different dashboards for different groups of users, so that each group in your organization gets the information that they want to see. You can create users and groups of users with different roles, so that certain people may have read-only privileges and other people have administrative privileges. You can also control who sees what. Users and groups are a great way to organize alert routing because you have escalation chains that specify groups of people. LogicMonitor dashboards are a great place for any metric that you want easy access to, or that you're really watching day to day. You can have as many dashboards as you need, so each team can have dashboards showing the data that's important to them. In this account, for example, We have a dashboard named Active Directory that shows metrics that would probably be used by members of our server team. And we have other dashboards that would probably be more specific to the networking team. To add a new dashboard, select the drop-down menu with the list of dashboards and click Manage Dashboards. We'll select Add, and we have 3 options. A shared dashboard is a dashboard that can be viewed by anyone, but you can restrict particular users from seeing particular dashboards using user roles, which we'll go over in a few moments. You can add widgets to your dashboard using the Add Widgets button. A drop-down menu will appear with the different types of widgets that are available. I'm going to go through an example of setting up an advanced custom graph widget, since it's a bit more complicated to set up than some of the other widget types. Advanced custom graph widgets let you see a metric for multiple devices on one graph, or even multiple metrics for multiple devices on one graph. The simplest one to start with is a CPU graph. Let's call it Top 10 CPU. We'll set the vertical label to %. Earlier in the webinar, we talked about data sources and data points. A data source is a group of data points, and each data point is a single metric. So since I want to see the CPU for all Windows servers in this account, I know I want to use the WinCPU data source, since that contains the CPU busy % data point. So I'll add a data point here. We'll set the group field to all, the device field to all, and note that in turn the system automatically wildcards these fields for you so that all devices in all groups are triggered here. And then we'll set the data source to WinCPU, and we'll wildcard the instance field, and we'll set the data point to CPU busy %. And then we want to see the top 10 results. We'll click Save. Now finally, we have to select a graph line. In this case, we just have one data point, so obviously that's going to be the data point for our graph line. We'll select Save and save again, and then we can go back to our dashboard and look at our graph. Now, a cool new feature in the UI is the ability to change the size of widgets. You can actually just drag the bottom right-hand corner of the widgets to resize them. Now lastly, we're going to take a quick look at users and roles, and how to set up specific user permissions. So in the Settings tab, let's navigate to the Roles section, and the administrator in the account has access to everything, obviously, but it's possible to set up users that only have access to specific sections of your account, and you do that by creating a new role and assigning certain permissions to that new role, and then assigning that role to the users you would wish to have those permissions. Especially in large organizations, it works well to limit access to just what's needed so that you don't end up with 80 admins. So let's add a role. We'll call it Limited Access Dashboards. You can configure the specific permissions for each tab of your LogicMonitor account, and specifically whether this role should have view permissions, manage permissions, acknowledge permissions, or whatever permissions are relevant to that particular tab. If you don't give a user any permissions for a particular tab, that tab won't appear when they log in. For example, I could set up a role that is limited to viewing only that one dashboard that we just created. To do this, I would select the View checkbox for that one dashboard. I'll click Save. Now I can add a user account with that role assigned to it. So we'll navigate to the Users section, and we'll add a user. And this means that when the user logs in, all they'll be able to see is that one dashboard we created on the Dashboards tab, and no other tabs will appear. So I'll quickly go through this process. And I'll assign the role that we just created. And that's all there is to it. If you'd like more information about dashboards, roles, or users, there are detailed articles available at help.logicmonitor.com. So that concludes the material for today's webinar. We are now going to go to Victoria for Q&A. So if you guys have any questions, you can enter them into the GoToWebinar interface at this time.
Okay, so it looks like our first question is about our new mobile app that we recently released. It says that you see we finally released an Android mobile app, and what is the best way to give feedback about the app? Yes, we did. We did finally release our Android app, and there's actually a feedback option right within the app, so that's probably the most direct way to give feedback. You can also use the feedback button in your LogicMonitor account, which you'll see anywhere on the new UI toward the bottom on the right-hand side, and that goes straight to our product team. Okay, we have another question here about time-based thresholds and when you would recommend using a time-based threshold instead of a time-based escalation chain. So the time-based thresholds will actually set it so that the alert won't even trigger at all. So essentially there will be no alert during a certain period of time instead of only turning off the routing like you would do in a time-based escalation chain or handling it differently. So if there's a situation where you want to completely ignore a condition, based on what time of day it happens at. For instance, if there's something overnight that you don't necessarily care about in the same way that you do during working hours, you could entirely suppress the alert by changing it to a time-based threshold instead of just suppressing the routing by doing a time-based chain or setting scheduled downtime. All right, it looks like that is all the questions we have. All right, well, thank you for joining. We'll be sending out a copy of the webinar recording following this call. Thank you.